Hi everybody. Okay, now we'll be talking about data link error control. Two types of error can occur during transmission of frames from one device to the other. Okay, one of them is called as content error and the other error is called as flow integrity error. Error which is there in the received frame. Suppose this frame is received and there is error in this frame. So this such kind of error is called as content error. Okay, and flow integrity error refer to a lost frame or a duplicate frame, and same thing with acknowledgements. Okay, so data link error control take care of both types of errors. Now how these content errors are detected? Contents error are detected using parity check or cyclic redundancy check bits. Okay, they are always added as a trailer in the frame. Okay, these bits are used to actually check if there is any content error over here. Usually the span of check starts from address field to up to this field over here. They will never check flag, because if the flag is wrong, the frame will never be detected. So it starts with the span of check of this FCS will start from address to FCS. The most common method of content error correction is simply retransmission of frame. What will happen is that the receiver informs the sending end of the error and the sending end retransmits the frame again. Okay, now for flow integrity errors there are many other methods, okay, that we'll see later. Now we'll just discuss error controls in your stop and wait mechanism. Okay, we'll first see error control in stop and wait flow control mechanism, and then we'll see error control in your sliding window mechanism. Okay, now error control in stop and wait mechanism, there are three methods. One is stop and window using timeout, and then second method is called stop and window using negative acknowledgement, that is NAAC, and then the third method is stop and window using numbered frames. Okay, we'll take each one of them. Okay, all three are very easy, so I'll try to make it easy for you all. Okay, so the first thing is stop and wait using timeout. Now this is very simple. Okay, we have a sender, we have a receiver. Now we will assume that only A is sending to B, and frames are sent from A to B only, to make it simple. Okay, and then we'll see how it is. Okay, so A is the sender, B is the receiver, and this fellow send since it is stop and wait mechanism, so initially as we have discussed that it doesn't have any numbers, so all the frames here are numbered as D, D, C. It doesn't have numbers, and then you will see if at all numbers are required for this method also. Okay, so what happens is that the first frame is sent from A to B. It is received properly by B, okay, and then what happens in stop and wait method is that this fellow B will send acknowledgement that it is received properly, and then this guy waits for that acknowledgement. Only after it gets the acknowledgement, it will send the next frame. Now this D is different from this D. It is not the same frame, it is the next frame. Since it received acknowledgement, so it will send the next frame. Now here there is one more thing that is needed to be discussed over here, is that the moment when this D is sent, a timer is started. Okay, now here it is mentioned as T0. Now we can take an example, just an example, okay, maybe 5 milliseconds or 2 milliseconds, a timer for 2 milliseconds. Okay, we will see what is the importance of the timer and why it is required. What happens over here is that this A, okay, is sending the second frame. Okay, it sent the second frame. Now what happened is that it did not now this receiver did not receive that frame. So if it doesn't receive that frame, why will it send acknowledgement? So what will happen is that this fellow, who now the sender will wait for timeout that was we had assumed that around 5 milliseconds. Okay, this is just an assumption, the actual time might be different. So it will wait for a total time of 5 milliseconds for their acknowledgement. If that acknowledgement doesn't come within 5 milliseconds, what will happen is that it will retransmit the same frame again. And what happened over here is that again the sender send the same frame. Now this D and this D is same. Okay, so it sent the frame and then it was received on the other side, but it was received with errors. So since it was received with errors, what will happen is that B will not send acknowledgement in this method. Okay, the B doesn't send acknowledgement to A. Okay, now what happens is that this D, this sender will wait for another 5 milliseconds. This is the timeout which is there, okay, and it will wait for the acknowledgement to come. If it doesn't receive that acknowledgement, again it will assume that something has happened, okay, and then it will send the same frame. Now this D and this D are all same. It's trying to send the same frame, okay, because it has not received the acknowledgement. Now what happened over here is that the sender sends the same frame again. Now it is received properly. Now yes, the frame is received properly at the receiver, okay, and then because it was received properly, this guy, what it does is that it sends the acknowledgement for the received frame. Now there are two cases which are shown in this particular slide, is that the frame is lost, the acknowledgement is lost, okay. So the sender doesn't receive the acknowledgement. So what it does is after 5 milliseconds it will send this same frame again, because it did not receive the acknowledgement. So it sends the same frame again. So this D is sent again, and it again, to its bad luck, it was received properly. So now this fellow and this frame is same, okay. And then what happens is that after some time, after it sent the frame, this acknowledgement which was sent over here, it was received. So what it will assume that this frame, whatever frame it said latest, okay, is received properly. Now the big issue over here is that now it has received two frames. This is one frame and this is the other frame, okay. Both the frames are same. That is how duplicate frames can come, okay. All have understood, hopefully, okay. Now what happens at the receiver is that it does not, now for him, these frames do not have any number. So what it will do is that it will keep both the frames, and because of this it will create errors at the receiver, okay. If they had numbers, the receiver will have differentiated, okay, this is and this value is the same. For example, if this was D1 and this was D1, they will have found out that this was the same frame, okay, and the duplicate frame has come, and it could have removed the latest one which is received. But since it has no numbers, it still keeps the duplicate frame. So this is how stop and wait using timeout works, and we have seen what are the issues with the stop and wait using timeout, that it can receive duplicate frame. Now to improve this, they what it did is that they invented one more method, something called as stop and wait using negative acknowledgement. It is the same thing, only that one negative acknowledgement is extra. Over here again we have sender and receiver, and it sends the frame. This fellow receives it properly. Since it has received properly, it will send acknowledgement to A. So this guy is happy saying that okay, now it has received whatever it has sent, it has received properly. So it will send the next frame. Now this frame is not same as this. So this is the next frame that is trying to say. Here also it maintains the timer T0. Okay, we have assumed that it is 5 milliseconds. Okay, so when the moment it sends D, okay, what happens that this frame is lost. Okay, it is not received by B. See, if it is not received by B, this fellow doesn't know if anybody has sent the frame, so it doesn't send any acknowledgement. So it doesn't send any acknowledgement, this fellow will not receive any acknowledgement. So what this fellow will do is that he will wait for another 5 milliseconds, and it will again send the same frame D. Now this frame and this frame is same. Now see what happens. Okay, now see, again the sender A is sending the frame. Okay, now this frame was received on the other side, but if you see it properly, this frame is received with errors. Now this is something different which is there in this method. Now the receiver knows that the frame is received with error. Immediately it will send negative acknowledgement. Okay, immediately in the previous method, if you see, when the frame was received with error, it did not send anything. So the sender had to wait for full 5 milliseconds. Okay, if this fellow had told this guy that Baba, it was received with errors within 1 millisecond, at least 1 millisecond, 4 milliseconds would have been saved. Okay, since the timeout is 5 milliseconds. Now what happens over here is that the minute that the frame is received over here, and this guy knows that there is an error over here, immediately it sends negative acknowledgement. Okay, so the sender need not wait for continuous 5 milliseconds. So it knows that when it receives this negative acknowledgement, it will come to know that the file was received with error, then it has to send the frame again. So it sends the frame again. Okay, now this D is same as this D and this D is same as this, so these three are same. Again it sends, again it was received with error, so it again sends negative acknowledgement. So what happens over here is that there are two things which is shown in this diagram. One is this arrow where the negative acknowledgement is lost. So what this fellow does is that the sender again has to wait for a time of 5 milliseconds. Okay, so what happens is that after 5 milliseconds it will send the frame again. Now then it sends now this frame is same as this frame, this frame is same as this frame, and this frame is same as this frame. It's trying to send this fellow again. It sends it, this frame again. It is received also properly. Now see, it is received also properly, but this negative acknowledgement which was sent for the previous frame, from somewhere it appears over here. Now this frame was received properly, but since this negative acknowledgement was received by the sender, what it will assume with this is that this negative acknowledgement is for this frame that it has sent. Actually this frame is properly delivered and received also here, but because of this negative acknowledgement getting received after this D was sent, it will assume that something went wrong with this frame, so it will send it again. And what it will do is that again it will send after timeout. Okay, so this again what will happen is that this frame will come down, and to its bad luck this frame was received in proper condition. Now what happened at the receiver is that what is the issue over here? We received two frames which are same. This is how duplicate frames are there. Okay, and then there will be problem over here. Okay. Now the third method, error control using numbered frames. Okay, now what is done over here is that it is the same very thing. It is combination of first and second method, but there is something different. If you can see here properly, the frames are given numbers. Now this is slightly different than what was there before. Now see, stop and wait using negative acknowledgement, we have D over here. The frames are not given numbered. Here also using timeout, the frames are not given numbers. Now here the frames are given numbers. Okay. Now what is happening over here is that now if you see here the frames are only given two numbers. Okay, that is D0 and D1. Okay, and then the next frame will be called as D0 and the next frame will be D1. So it is like it starts with D0, then D1, then D0, then D1. Now why only two numbers are given? Why not D0, 1, 2, 3, 4, 5? It is because only two numbers are given, because only, see, at a time only one frame is sent. So if you send one frame, so it is okay to give two numbers. No? So if the first frame will be D0, next frame will be D1, the next frame will be D0, and next frame will be D1. Okay, so hopefully everybody has understood why there are only two. This is asked for a why was, okay, why there are only two numbers. Okay, because only one frame is sent at a time. Okay, now this method is very simple. Okay, again D0 is sent, D0 is received. Here the acknowledgements are also numbered. Okay, and then ACK1 means I want the next frame. Okay, so D1 is sent. There is a timer also. It will wait for, it is not received over here D1, so it will wait for 5 milliseconds, and again it will send over here. So it is received with errors, so it sends a NEC1, meaning again you please send me the D1 only. Then what happens over here is that it is trying to send the same frame D1 over here. This D1 was received on the other side, again it was received with errors. So if it is received with errors, it will send what now? NEC. Okay, so what have here? There are two cases which are shown. One, it is the NEC is lost. So if the NEC is lost, what it will do? This will did not receive anything, acknowledgement also and negative acknowledgement also. So what it will do is that it will wait for a timeout. Okay, for 5 milliseconds, and it will again send the same frame again. Now this is what happened. Now this frame is sent. Okay, D1 is sent, D1 is received. Now everything. This was received properly, but what happened after some time? This NEC, which was sent for the previous frame, is received over here. Now, when it will read this, it will assume that this D1 might have not received properly. So again, it will send D1 back over here. So what happens over here? We received two D1s over here. But the good thing about this case is that now the receiver can find out that there are two frames with the same number, so it will discard the latest one. Hence, this method is better than the previous two. Okay, thank you very much. Hopefully you have understood.